What happened? Oh wait, that was still part of day one. So my videos are gonna be all like screwed up. So we will sort that out later. So officially day two, when I thought I was doing day two previously. Actually back up. Anyways, you stop following through time, catch your breath, current year, yada yada yada. Plus I feel okay. So another voice, well, actually, we've been working on a new kind of suit that would let him fit through the tiny space of beds. But I have heard that a few years ago they lost the prototype fabric, yada yada. Wouldn't they have had enough fabric to fill several boxes in the warehouse? Maybe sort together. IDs should be similar. Can't search everything. Good night. I'm looking. Scanning everything. To produce a list of likely candidates. A puzzle input. Okay. To make sure you didn't miss any, you scan the candidate boxes again, counting the number that have an ID containing exactly 2 of any letter. Okay. And separately counting those with exactly 3 of any letter. And for example, let's see the following list. A, B, C, D, E, F contains no letters that appear exactly 2 or 3 times. Okay. This contains 2A and 3B, so it counts for both. Okay. This contains 2 B's, but no letter appears exactly 3 times. This one here has 3 C's, but no letter appears exactly 2 times. But 2 A's and 2 D's, but it only counts once. This one has 2 E's, contains 3 A's and 3 B's, but only counts once. Okay, so of those box IDs, 4 of them contain a letter which appears exactly twice. And 3 of them contain a letter which appears exactly 3 times. Multiplying these together produces a checksum of 4 times 3 equals 12. What is the checksum from your list of box IDs? Okay. So let me think this one more time. 2 A's and 3 B's, so it counts for both lists. 2 B's, but no letter counts 3 times. It only counts once. So I say, if I'm not right, I have nothing. I get 1 in both. This is 2 2's. This gives me 2 3's. 2 2's and 2 3's. 3 2's. 4 2's. and 3 3s. So 4 2s and 3 3s. 4 2s, 3 3s. Got it. Okay. Let me go fix up my project here because I was doing this wrong before. So move that there. And I'll reuse that input data folder. So I get my input. Oh boy, oh boy, oh boy. This guy will be quite interesting. So, all right. So now I have my data. Data 0 looks like this. So I need to find is let's see here. I need to basically count the letters. We count the letters first. Let's see here. Count the letters twice. If I count each letter. Okay, let's figure this out. For each line in data, for each letter in line dash split everything. Can I do that? I might do this though. Data dash splits this. These are going to use. Wait, maybe I got to split like this. And I'm going to put the count, make sure I'm not doing something really weird. $28. Going to be the same thing as um, data dot 6. Okay. Can I do this though? Maybe I just do this. Okay. I want the block each letter. So we're doing data dot to character array. Is this what I want? That's what I want. All right. So now, to letter dot counter equals locate a hash table, and I do counter dot letter equals 1. And then I need double, triple, that. All right, so this will loop it. I get a hash table. And then if I have if count dot values equals double plus, and then triple, failing 3, and I get, what was that calculation? I get double times 6200. Correct. Okay. So to explain the first problem, so what's that kind of fast? Is that I didn't need this, anyways, and I didn't need that experimenting. So I walk each line, then I create a hash table. Okay, and I'll use it later. I want each letter in line and convert it to a character array. So this guy gives me basically one character for each one. Now, the hash table starts out empty. If the does not exist, he's effectively null, which is 0. So the first time, I'm basically adding, I'm giving it a 1. Come the second time a 2, another time a 3. Okay? So basically, for every letter, I will get the count of each one to an n time. I walk the list once to get the count for each character. So then my last size here, my last line is this one. Okay. The counter of my last letter, W, it is a, so my counter of letter is 2. Now, here with hash tables, the hash table dot values is a list of all values inside that. So if I just run the counter, actually let's do that instead. I just run this here. Actually get a little table here of the count of each one because I indexed and I added it in. And what I'm doing is I'm checking just the values, and if any of them equal 2, this one's true. This is a hack. I should say maybe 2 in values, or this things might be more appropriate. Yeah, let me just do that. And contains 3. So the thing I had before that, plus plus increase whatever this value is. So I'm counting my doubles and my triples. Yep. And at the end, I'm looking there to give me what our end result was, which I was able to enter it and go on to the onto that section. So let's move on to 2. All right. Confident that my list of box IDs is complete. Ready to find boxes full of prototype fabric. Boxes will have IDs which differ by exactly 1 character at the same position in both strings. For example, given these box IDs, all right, IDs of A, B, C, D, E, and X, C, Y, E are close. They differ by 2 characters back and forth. However, IDs for G and for G differ by exactly 1 character. Third, H and U, those must be the correct boxes. What letters are common between the 2 correct box IDs? The example above, this is found by removing the differing character from either ID, producing this. Okay. So this is more interesting in that we now need to compare the strings with each other. And find 2 that are super close. Let me think. My gut tells me I want to sort everything, because that will more than likely get pairs next to each other that differ by 1 character. But the issue is that there's somebody alphabetically, it's like say the first character that's different, they'll be miles apart. So that ultimately doesn't actually tell me a thing. But how do I keep myself from comparing everything to everything else? And differing by 1 character though, excluding 2, but it doesn't matter what the value that character has. This is interesting. So how do I not compare everything to everything else? Right, that's my first question, is how do I narrow the inputs so as not to compare to a crazy amount of comparisons? I do not have a quick answer to this. Or if we do a matrix and we can walk everything, is there a way to not like alphabetical? Because they differ by 2 are 2 characters. The second and the fourth. However, the IDs provides after 1 character. Third, and those must be the correct boxes. Okay, so I'm still thinking here. 1, 2. Well, let's start with a dirty solution, I guess. For each do primary in data for each Okay, so first off, this is like n squared, right? So it's ugly. Now I have I have 2 trees that I can compare with each other. And if we walk them, if count equals 0 for index 0, index is less than primary dot length index plus plus. If primary index equals secondary index count plus if count greater than 1, continue. So after if, I think I take the character out. If count, if index equals this, index. Okay. And then my if count equals 1. Exactly. I pass the whole thing onto break main loop. So it is call this guy loop. And just for clarity, we're going to continue the second loop. It does it by default, but just as no confusion. Okay, so if I do this, if I break, can I do oops, there's the time. It's special type, isn't he? Recession test. Remove, say 4. Okay, how do I do this? Primary. I do 0 dot dot to if index plus primary dot right. Let's see if this finds something. Okay, so I think what will happen is we walk 2 loops, then we walk each string. I'm doing some counting here. And if I make note of the index, so I know which character is duplicate, and then I will, if I find a second if greater than 1, I go on this one and just keep going. But if I find the duplicate, I break the main loop, which means that it got to the end of the list on exactly 1. Otherwise, it's going to continue to run. So let's just run all this. And then we go primary, there, and those guys are same right there. Primary equal secondary. Oh no, they aren't. If index 20, let's say primary J, that one there. I see it now. Restruct the J then. And submit. Correct. Okay. This is ugly. I think it's super ugly. Let me drop that. J. I am going to cut the video here, and I'll take a break, so I'll pick these back up later. I want to think through this one. I feel like, okay, so first off, the for each loop and loop, I know it's like big O notation, right? Those that care, it's n squared. Now, if I turn these into 4 loops instead of each, or I start the index and I run through it, I can probably get this to like log it, I think. The issue is these both start from the beginning of the list every single time. So we're doing n squared, which basically means that we will basically compare every string to each other at least twice. Primary is the very first one. I mean, even out of the gate, I take the first record of data and then the first record of data, and I compare them together. They'll be an identical match. Like, I should be starting offset by 1, right? This should be the first record, this should be the second record, this should go to 2 to 3 to 4 to 5 to the end. Then the outside should go to the second record. This one should be the third record instead of the second, and string. So that's like the first most obvious change to make. I don't know if there is a alternate way to classify this. I wonder if I I don't know. I'm gonna have to loop back on this one. Like, I actually want to solve this a more elegant way. So I'm gonna cut this video here and actually just go to bed for the night. But we'll wrap this up as the official day 2 video, and we'll see where we go from there. Thank you for joining me.